Okay, today, gonna try to get that animation for our taxi working. I don't got too much time today because I gotta go help family cook Thanksgiving stuff. But if we can get animation working on our taxi, it'll be a success. So we're gonna need. Remember the function we're gonna be using to animate. It's called set viewport, which takes a couple arguments, and then we'll have to set the viewport on our taxi one sprite according to a certain amount of conditions where we, do the animation. So I'm gonna, in order to save time, I'm gonna look at how we do the animation here for our ostrich. Now it's probably more, the best way to do it would probably be to look at the no, I don't know what to do. So the thing is, it's like we can do it variable or since I feel like the DX of our taxis are going to be stable, we don't have to do a variable sort of animation scale. But yeah, what would we do? So we give ourselves an FPS, frames per second. And what we do is we're deducting our animation timer by our frames per second. That's not quite what I would want to do. I'm curious what I did with maybe the vulture. Vulture animation, so we do the same thing. I guess we'll just try to figure it out. I guess we'll just try to do it ourselves. So we're gonna need a frame integer. So self frame. Okay, we're gonna start on frame 1. And then we're gonna need a animation timer, which we're gonna say is, I don't know, 0.3, third of a second-ish. That'll trigger the next frame of our animation, right? And then we either want FPS so that we can scale the speed appropriately, or we just mess with the animation timer, So let's say that in our update function, we're going to take our animation timer and we're going to deduct it by dt, which is the change in seconds since last frame. And we're going to say and you can't just state this, you have to say what to do with it. So we're saying animation timer gets itself minus dt, and then we're going to say if self animation timer is smaller than 0, then we want to do a couple things. First thing we want to do is reset our animation timer, and then we're going to increment our frame, and then self frame gets self frame plus 1, and then we're going to set our viewport according to what frame we're on. So let me look at the set viewport arguments. Is an x, a y, a width, a height, and an atlas dimensions. X, y, width, height, atlas dimensions. So x, y, width, height, atlas dimensions. We're going to put self.atlas with the get dimensions function to get that, and then we need an x and a y, and our x is going to be our frame. It's going to be our frame offset. So x, y, width, self.height, atlas dimensions. So this x is not going to be frame, because frame is going to be 1, 2, 3, 4 loop. Yeah, 1, 2, 1, 2, 3, 4, and then back to 1, 2, 3, 4. So it needs to be our current frame, which starts out as 1. Okay, so here's the thing. Yeah, if it's frame 1, we need it to be 1 for the 1 pixel buffer offset on the x. So if it's frame 1, we need it to be 1. If it's frame 2, we need it to be width times 1 frame. How do we say that? Let me look at how we were doing it based off of on our self-atlas. Okay, so look, we do it by the width. So we say, see, this is what I'm talking about. So we take the frame, we minus 1. What that'll do is 0 index us for our x offset. So we're saying current frame, which would be 1, plus its self width times self frame minus 1. So if it's frame 1, 1 minus 1 is 0, 0 times width is 0, meaning our x offset would be 1 on frame 1. Now if we go to frame 2, it would be 2 plus the self width of self frame minus 1. So that would give us 1 width plus 2 pixels offset on our self frames. So yeah, this is the math I'm looking for. So we're going to say, instead of doing a field of an x offset, I'm just going to put it in parentheses here. Well, let me see, parentheses, and then it goes, so parentheses there. Oops, what? That should be, so on frame 1, I guess we need to do this first. We're going to set the viewport to a frame worth of pixel offsets, and then offset it by how many sprite quads we are going into our frame. And then we're going to increment our frame number. And then what we need to do also is say, if self.frame is greater than 4, meaning we would be on the 5th frame, then we're actually back to frame 1. So self.frame gets 1. And then we set our animation timer to 3, and then every frame, we're going to be decrementing that, so every third of a second, animation timer should be smaller than 0, which should trigger our set viewport on our taxi sprite, and that's what we're rendering. So if we did this correctly and passed in the correct arguments, and this nonsense is looking right, then it might be animated. But we do have to update our taxi. So in our play state, we're instantiating a taxi, and then we're going to have to say, hey, taxi 1, update that given the DT of play state. and then we're rendering it. We're rendering it somewhere. Taxi render right here. So let's see if, with any luck, we've got a taxi walk-in. Not quite. The set viewport isn't working. And it changed colors. So we need to do something different. Animation timer gets animation timer minus delta time. Animation timer's smaller than 0. We need to set viewport. We just put in a random, like, halfway inside of a vulture here to make sure the set viewport is working on an animation timer, and it is not. So something is going weird. Animation timer gets deducted. We set the viewport when it's smaller than 0. Let me print out what the taxi, we're gonna say taxi anim timer. So taxi anim, and it's gonna be our taxi1 object, taxi1, and it's gonna be the field of animation timer. That's what we're rendering to debugging. That should be deducting. Oh, it's not deducting. I mean, it's constantly deducting, but it's getting reset. So well, the thing is, I think we're initializing. Look at this. We're initializing our taxi in the update function, which is causing it to get instantiated every single frame, which is wrong. So what we will do is instantiate it up here in the init function. We only have one, and then it might be fixed now, even though we deleted the proper self.frame, oh god, logic that we had. It should be the frame -1, this one. Here we broke it out into a variable that we assigned x offset, so it looks prettier, but we don't really need that. But that's why we did it in x offset, because this is like a little bit of an eyesore to look at. But let us see if that fixes our problem, but also we need to set color to white before we render as well. So function for that is love.graphics.setColor, and then it takes in 4 arguments. We want maxed out on the red channel, maxed out on the green channel, maxed out on the blue channel, maxed out on the alpha. Now let's see. Hey, buddy! Check it out! So it needs to be maybe twice as fast as that. So we can go taxi, animation timer, let's just say 0.1. So every 1/10 of a second it'll animate, and we can turn off our debugging because it's working now, and then check it out. Yeah, it needs to be faster than that even. Look how cool that is. That's cool. So we're gonna say in our taxi, what if we say 0.01, just to be crazy? It's going at the same rate. Oh, because that's why we need to reset it to be the same. Okay, so let's just do every 1/10 of a second, so 10 times a second, it will change, and then we just need to reinitialize it to that upon an animation timer. Yeah, cool. You might need to be a bit faster than that. So let's say 0.04, maybe, because it's going to be running along to go pick up that jockey. And then, maybe a bit too fast, maybe 0.06. Nice, I like that. So if you imagine him running, alongside the ground, that probably looks pretty good. I like you could see like the head bob is at a pretty good speed. All right, cool. We've got animation on our taxi class. We'll have to implement which way it's facing, so we need to flip it on the x-axis with the correct offset if it's facing left. We'll need to eventually add collision detecting both on the ground and the sides. We'll need to add jockey collision detection. We'll need to deinstantiate upon collecting of a jockey. We'll need to give it the AI to heat seek the jockey, but also to flap its wings in a manner that allows it to get to the jockey. Oh, check it out, the pterodactyl, I forgot, that's sick. Cool, I'm happy with that. I'm gonna call it a day because I gotta go head out to the family, but I'm really glad we got at least some progress. We can say we added, I think it's good practice to run a git diff before you commit just to see. We added a frame and an animation timer to our taxi class. We did our animation for our taxi, and then we moved the init to the init instead of the update of our taxi, and we render our taxi. Yeah, pretty solid. We have a git add everything to the staging area with a commit message saying added initial animation cycle for taxi sprite 1. Get pushed to our origin main. Okay, cool. Yeah, tomorrow we'll work on those other things. We're going to be giving it a DX, giving it gravity, giving it collision detection so it can walk on the ground, and then we'll have to figure out how to figure out the AI for how to get it to chase the jockey. Then we have to probably play the original and analyze where the jockeys come in from. I don't know if it's random or if they always come in from the top. Not the jockeys, the taxis. And then we'll have to start implementing all of those intricacies of spawning the taxi when a jockey is spawned, giving it the heat-seeking AI, and then the collision detection with the jockey. And then once that's underway, then we do the tier system, because once the jockey collides with once the taxi collides with the jockey, then we need to upgrade said jockey's tier system up to the next vulture. Then we got to worry about the next vulture's AI and the next vulture's sprites and all of that goodness. But we're getting there. I'll catch you guys tomorrow, and I hope you guys have a good Thanksgiving if that's what you guys celebrate and all that good stuff. Catch you.